guys, welcome to my little world of YouTube vlogging. Oh my god. So yesterday, last night, I am talking about what's gonna be the chemical bonding, right? I'm talking first with hydrogen bonding, mga palangga kong gitad. So basically, this is all about chemical bonding. Wait, may kalkada kong buhok. Diba? Okay, comb my hair. Oh, nakakalog ka, di ba? Okay, it's fine now. My hair was so scattered. Now, I'm done with hydrogen bonding, okay? Okay, hydrogen bonding mga palangga. Okay. Second, I need to focus on the ionic bond interactions, ion to ion interactions, right? Ion to ion interactions. Okay? Ganon. So, ion to ion interactions. What do you understand by this, guys? Okay. Ion to ion interactions are basically talking on the electrostatic forces involved in the combination of the metals and the non-metals. Just like that. Okay, so when different charges combine with each other, they will be able to achieve each specific polarity, meaning opposite polarity. You get the point? This is also the basis of, what do you call this one? Magnetism, right? In physics, if you can still remember, and it's also related to electromagnetism. Okay, something like that. Okay, so a magnetism that deals with purely electrons. That's why electromagnetism. Okay? Unlike poles repel, no, unlike poles react, the same poles, repel. Okay? Positive repel, negative, repel also. But positive and negative attract. So that's the law of polarity, law of magnetism, or law of electromagnetism. So it will be applied here in the ion to ion interactions. For example, mga palangga, so this normally happens to metals, to non-metals, but it will never be happening to covalent molecular compounds. Meaning to say, it will never be happening to non-metals to non-metals. Okay? What are those non-metals to non-metals? For example, carbon dioxide, carbon monoxide, hydrochloric acid, hydrochloric acid, certain hydroiodic acid, something like that, ammonia, NH3, ammonium, okay? So these are all gases, okay, or non-metals banded together. But if you talk about metals plus non-metals, this is gonna be the case, ion to ion interaction. For example, I will go back to, let's say, sodium chloride, because sodium chloride is a very good example of this ion to ion interactions. Okay, for example, something like this. So, I have sodium chloride, right? Sodium chloride. Oh, ganon. So let's take the normal chemical reaction of sodium chloride. You can split sodium chloride if you don't do anything. Okay? So the first thing to do is you're gonna add water. Okay? Secondly, you're gonna add whatever type of solvents you want. As long as the sodium ion positive one and chloride negative one will be dissociating in your solution. It's not limited only to water. Get the point? It could be inorganic solvents, organic solvents, as long as you need to introduce something, a solvent, okay, so that it will be dissociated. Okay? Something like that. So if you will never introduce something, this will be a neutral compound. Nothing happens. Okay, that's number one. Through solution, mixture, something like that. Number two, either we need to undergo heating process. Okay, heating process meaning to say we introduce at a certain high temperature so that we can be able to decompose sodium chloride solid, okay, to something sodium ion and chloride negative, something like that. Okay, because this will not be splitted if you will never apply, heat also. Get the point, mga palangga. But it's going to be more on the chemical reaction related also to these stations. It's be clear the difference for that. Okay. So, for example, mga palangga, if you need to heat this one, so let's show delta. Delta at say temperature of at room temperature, so it's not very hot, right? So let's say you increase Room temperature meaning 21 degrees Celsius, right? Or ambient temperature. So we need to increase that for about something like 60 degrees Celsius. It's gonna be hotter now. Okay, so if we try to apply 60 degrees Celsius for this, or let's say 100 degrees Celsius, the boiling point of water. Okay, okay, like that 100 degrees Celsius. Okay, the boiling point of water. Okay, ganon. So, we decompose this into, okay, sodium, okay, sodium, solid, plus chlorine gas, diatomic chlorine, okay? So you will be able to produce an atom of sodium, but it will become charged to positive one. It will become ion. As long as it will become charged, it will turn to ion, ha? Okay. And then something like that, your chlorine will become chlorine gas diatomic. So G, ganon. So sodium solid and chlorine gas. The chlorine gas will vaporize into the atmosphere. And what's being left is your sodium solid that in the form of, let's say, a coagulate or something like a residue or something like a solid. Okay? Whatever, as long as it is a solid substance. What do you call that? It's up to you. So normally it's also a salt, right? Or it can be also an electrolyte. Okay, it depends on what you are referring to, but as long as it is a solid substance. Okay? Something like that. Now, this is you balance the chemical reaction. 2 atoms of chlorine, you have to put 2 here and 2 sodium here. Okay? This is the decomposition reaction. One type of chemical reactions. Now, in your ion-ion interaction, you are not concentrating in these chemical reactions. Okay? You are concentrating to the dissociation chemical reaction, dissociating. So meaning to say, the other option is to add water. Say for example, sodium chloride plus water. Okay, so you're not trying to have the theory of Arrhenius theory, right? Something like that. You're gonna produce an acid, okay, which is hydrochloric acid and the sodium hydroxide. Okay, so balance the chemical reaction two hydrogen. Even though you are still dissociating, you need also to balance. The only difference in dissociation, guys, you need to take in charge. You need to take the charge. Okay? So, because in a normal chemical reaction, you don't have to go with the electric charges. You are only concerned with the atoms and the moles. But here, in the dissociation chemical reaction, okay, you need to account the number of atoms at the same time, the number of electrons at the same time, the charges. Okay? So say, we produce an acid, HCl, okay, this is now aqueous, right? Aqueous. Okay, like this aqueous. Ganon. Because you produce iron water. Okay. Now you will take only the negative part of HCl and the negative part of HCl and the positive part of HCl, which is the 1. And then you take only the OH negative of sodium hydroxide and the positive of sodium. Okay? Ganon. Now, since you are concerned with sodium chloride, because our example is sodium chloride only, you don't have to take the water. Okay? Like that. So take the sodium chloride and then put that in your ion to ion interaction. Okay? Because sodium is metal, chloride is non-metal. Okay? So, concentrate ka sa sodium and chlorine. Something like that. So, sodium chloride. Sodium, positive 1 na siya, which is our product of ago. Okay, sodium positive and chloride negative. Ganon. Okay. Now, this is ion to ion interaction. A positive ion, okay, a positive ion known as the cation, okay, and the negative ion, assure an ion. Okay. Normally, if it's not yet charged, okay, before charging the sodium and chlorine, before, zero pa siya originally, right? So, sodium is electropositive, something like that, and chlorine is electronegative. Okay. So, ganun. Kapag yung original state pa siya as sodium ba? Sodium in original state and chlorine in original state. Meaning, not charged yet, not reacting yet. Okay? Something like that. Neutral pa siya. Okay? All elements and compounds in neutral state, no charge yet. Okay? So, meaning to say, the charge is zero. Okay? You get the point? It will become charged only if you do something by heating, by adding water, or whatever you want. Okay? So that's gonna be the case. Okay? So we are now here splitted sodium ion and chloride ion mga palangga. Okay? Negative charge, one positive. So what responsible here in the ion-ion interaction is that this is the theoretical part, the electrostatic force. Electrostatic force. So the electrostatic force is the positive and the negative. O ganon. Now, sodium have the force directed toward the chlorine. Oh, ganon. So this is electrostatic force of sodium. So EF. Now I have also electrostatic force from chlorine or the chloride. So it will become EF. And they meet together. Like that, they meet together, these electrostatic charges, and then it will become static, meaning not moving already. So the net electrical charge is zero. Because positive plus negative is equals to zero. So we need to say, this is the net electric charge. Okay, net electric charge. Okay, net electric charge upon the interaction of the electrostatic forces of sodium and chlorine, and then the result will be zero. Now, they will be neutralized with each other. Ganon. Okay, neutralize with each other. Now, it's very clear that there is polarization. Okay, the different charges, positive and negative. So, polarization. So polarization occurs when there is a zero electric net charge due to the combination or the addition of positive ion and negative ion driven by electrostatic forces. Ganon. Okay. If the question in the theory in the future will say blank is an interaction driven by electrostatic forces, your answer will be ion to ion interaction or ion interaction or ionic bonding. So you should not be literal, but you should interpret in that way as long as there is a term ion. So ion to ion interaction, okay. Ionic bonding, something like that, okay. You get the point. And the ionic compound produced for that is an ionic compound, of course, common sense. Okay, like that. So most of the ionic compounds, or all ionic compounds, will exhibit electrostatic forces to achieve polarization. Okay, because there is a net electrical charge of zero, and then they will be neutralized with each other, the sodium and the chlorine. Okay, if there's no such thing as zero electrical charge, then it will not form ionic or ions. Okay, you get mga palangga? Okay. So, when you split sodium chloride into sodium and chlorine, you will never produce an atom. Take note. You should be particular. We should not produce an atom. We are not producing a particle. We are not producing a mole. We are not producing a molecule. Take note. This is theory. You are producing exclusively ions. No other. For example, in the theory examination in the future, will say, when we try to decompose sodium chloride by adding water, what will be the result? What will it yield? A, atom. B, molecules. C, okay, ang ganda nun ba? C, electrons. C, protons. D, ions. Your answer will be ion. Nothing. You get the point? Ganun siya ang theory question. Okay? You get the point. So, tempting kayo siya guys because these are all related with each other. The particle, the atom, the molecules, the moles, like that. They're related really. Okay? So, the only way is to, to take the distinction, meaning the difference among them. Could it be large difference or could it be slight difference? Something like as long as it is different. Wow. Okay, ganon. Okay, now let's try to accommodate or incorporate water now. How it will form the chemical bonding of ion to ion interaction. Okay, I will now show you. Charot. Okay, now let's take first the sodium will react to water. Okay, because we add water, right? That's why it dissociates to form an aqueous solution so that it will become charged, something like that. Now there is the water here, water galore, ganon. Water galore here. And we have also here the sodium chloride, ganon. Okay mga palangga. Okay. In this, if you try to put the Lewis dot structure, you can do the chemical bonding, guys, by using the Lewis dot structure. Put that in your brain cells. You cannot do the chemical bonding if no Lewis dot structure because you cannot have the bond. And that structure would represent the electrons, okay, the valence electrons in the outermost shell. Then you cannot connect to make a bond. B-O-N, so it cold. It is cold. Not cold kasi oil ga. Cold, B-O-N-D, bond, chemical bond. So requirement with siya ang Lewis dot structure. And you need to find out the valence electrons. So this is the water and this is the sodium chloride. Wala na siya yung chart eh. Let's say, bungkab din siya. So when I do the Lewis dot structure, bungkabo na po siya. I say, sodium, parent, sodium, ganan, chlorine, ganon. Now, take the valence electron. So, how many valence electrons in the sodium? I remember, sodium is an alkali metal. Okay, alkali group, group 1A. So, there is only one valence electron of sodium. Like that. Get the point mga palangga? Okay. It's here. Though this is also electropositive, but it's only one electron here. Okay? Valence na siya ha. Nagka-confuse sa electron lang. Okay. Now, ang chlorine, we have group 7A. Okay, group 7A, the halide family or the halogen group, something like that. Okay, and we have 7. 1, 2, 3, 4, 5, 6, 7. Oh, ganon. So, it will connect to the electron of the sodium. The sodium will give the electron to chlorine and the chlorine will accept only. Okay? Upon accepting, the one electron of chlorine will be connected to the electron of sodium. That's why we have only one bond. Something like that. Since I have 1, 2, 3, 4, 5, 6, this these are my lone pairs of electrons in the chlorine side. So 6 lone pairs, or what we call this in chemistry as the 6 unpaired electrons. We put that as U, E negative unpaired electrons, or we will say L, small letter A negative lone pair. It's just the same meaning. Also unshared. Okay, unshared electron, unpaired electron is just the same, and also lone pair, the same terminology, something like that. Okay, now we have 6. So basically you will say, oh my gosh, this is polar. Yes, sodium chloride will start to become polarized because we have negative 6 electrons remain, and the sodium also is 1, something like that, and then nothing because he donated to chlorine. Polarization takes place, something like that you see in your mind. Okay, now if there's a polarization takes place due to the different charges and also the valence electrons, then we can say that chlorine will be partially negative and sodium will be partially positive. Okay, now since sodium are partially positive, he wants another outlet to react to where? In which we have here the water is very thirsty. Okay, we have oxygen, hydrogen, like that, ganon. Okay, so oxygen, pila ang valence electrons sa mga palangga? 6. So 1, 2, 3, 4, 5, 6. The 2 electrons will be combined with hydrogen. Because again, oxygen is electronegative and hydrogen is electropositive. That's why hydrogen will give and lose its electrons to the hungry oxygen. Okay. See, ang kanang mga metals guys, maro. Okay? Because hangol ka sila. Even though they have the electrons, they try to keep it. They still long for others, the metals. They receive it. So, kuan sila hako kung sa tao pa sila, okay? So they will keep their electrons by themselves and they keep on, receiving and accepting the electrons coming from electropositive metals. Okay, like that. Get the point? Now, if we have 4, the oxygen here, and the hydrogen is nothing, there's a imbalance number of valence electrons also. Oxygen is 6 valence electrons, and hydrogen also 1 valence electrons, because again, hydrogen belongs to one group A. Group 1A, the same as sodium. Okay? Now, so we can say again, oxygen is partially negative and hydrogen is partially positive. Now take a look with the sodium chloride and the water. You will connect which is partially negative and partially positive, partially negative and partially negative. So the chloride negative will react to the water, the H here. Because partially positive hydrogen coming from the water and partially negative coming from sodium chloride. So this will connect as our band. Ganon. And then, the partially negative oxygen will also react to the partially positive sodium. React. Ganon. Ganon. Now, take note. So, the distance covered by here and the distance covered by here, so this will take the electromolecular, okay, or intermolecular interactions. Intermolecular interactions. Okay. In here, guys, okay, misablay siya kagamay because, we are referring to ions, right? But since we don't have a term inter-ionic interaction, okay, in English, it doesn't fall. That's why we still follow the molecular word. That's only for the purpose of naming. Not on the technical, how we are going to show the electrons. Kung imo yung tinudon guys, you're trying to distract, this will become inter-ionic interaction because we're referring to ions, right? Not molecules. Because I told you a while ago, molecules are covered only by molecular compound, which is non-metals and non-metals. But here, na-involve naman yung mga metals. You see? Sodium metal and non-metals of chlorine. Okay? So, na-deviate gamay ang atom dictionary, vocabulary, grammar for the word intermolecular interaction. Because there's no inter-ionic interaction, so we still use the word intermolecular. Okay, so forget that one. Intermolecular interactions or intermolecular forces between two partially negatively charged and partially positively charged that will react with each other. So our intermolecular interaction here and here also. 2. Ganon. Okay. You get the point? Muna siya. Or intermolecular interaction, or forces, or bonds. Okay. The same. Intermolecular interaction, intermolecular forces, and intermolecular bond. Okay. Now, if we have intermolecular, we have also the intramolecular forces, interaction and bond. But it's in between the water molecule and the sodium chloride because that's intra, within only. Inter meaning between two, between two compounds, sodium chloride and this water. Okay? But intra, within that one compound. Just like intranet and internet. Okay? You get the point? That's the analogy. So, if we have intermolecular interaction forces, bonds, between sodium chloride and water, we have also the intramolecular forces, interactions, and bonds within sodium chloride compound and also within water compound, something like that. So do not mix up the terminology also between intramolecular and intermolecular. Okay, something like this. This is now the ion-to-ion interaction. Okay, ganon. Now, this is the partial theory. And if we have to be comprehensive, we need to show what's going to be happening here. Okay? Like that. So let's say we take the sodium. Okay? Sodium first. Because we cannot accommodate the various structures of chlorine also. So sodium first. Okay, sodium natin. Ano to siya, no? Sodium is partially positive. Now, there's a water here. Di ba siya sodium? Okay. Di ba? Water, oxygen. So it will be yield like this. Okay. Oxygen. Ganon naman. Ganon. Oxygen. Reaction very ari. Water, 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 ganun. Water, 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 water. So, okay, since this is electrostatic charges, so it will be directed on the sodium. The electrostatic forces, as I told you, always directed to the center because they are polarized with each other. So you will say, going to sodium, going to sodium, going to sodium, going to sodium like that. Because this is partially negative oxygen, partially negative oxygen, partially negative oxygen. This is the comprehensive structures how sodium ion react to the water molecule. Okay, now it is the sodium and oxygen that combine. It's not the hydrogen because hydrogen is partially positive. It's impossible for a partially positive hydrogen and a partially positive nitrogen will be encountering with each other. That's not polarity because polarity is not the same charge. So opposite charge or opposite poles, P-O-L-E-S. Okay, like that. Okay. The same thing also with chlorine. If you have to put the chlorine here, ganon. So I have partially negative. It will react also to the HH2 bachuchu. Okay? So like this. I-react mo yung kuan. Sa chlorine. Directed also in the center of chlorine. And then we have also here water or ang H. Ganon. Ang H. Ganon. Ang H, papunta sa chlorine. So directed toward the center of chlorine. Ganon siya. Because the electrostatic forces are always directed to the center. Or else there will be no net electric charge if they will not be pointed to the center. That's why it will positive and negative. It will not repel. Okay, by the theory, so masablay siya. That's why it's gonna be the comprehensive there is that structure. Okay, now if this is the case mga palangga, okay, what's gonna be the water? Okay, the water is, right? Because it shared the electrons and very, not all are being completely shared with chlorine because the oxygen also have a valence excess of 5. Ang usaray gihatag sa kuan, sa hydrogen or sa sodium, sa gano'n siya, chupa-chucho. Okay? You got the point? Muna siya. Polar siya ang water. Okay? But sodium chloride is ionic compound. Okay? And that is also a polar ionic compound if we try to relate that to the polarity and the non-polarity of the molecule. Okay? Because as long as the valence electrons are not the same, okay? Like that, so it will not yield zero. Because negative, valence electrons of chlorine is 7 lang siya, sodium 1, so hindi siya mabalance. So that is polar siya. Okay? Polar, ionic compound. But since polar and non-polar is not really used in in ionic compound, it's limited only to the covalent molecular compound, the non-metals and non-metals, okay? But if we try to be strict, pwede sa siya, but normally not used. Okay? You get the point for the purpose of discussion. Okay? Like that. You get the point, mga palangga, mga masyadong tabo. Oh. That is our ion to ion interactions. Then, pwede sa, guys, now, you have an ionic compound. For example, let's say I have, nakakaloka, strontium. Okay, if I have strontium iodide. Wow. Strontium iodide. Okay, and then plus, let's say, I'll be able to take, CO2, okay, CO2. Okay, this is also ion dipole. Dipole na siya because diamond of oxygen. Okay, you get the point. So, ion to ion is exclusive only to ionic compound. Okay, ganon. You get the point, mga palangga. Muna siya. Okay? You get the point. So, mga nata sa ion to ion interaction, hydrogen bonding man na. So, ari ta sa ion to dipole. Charot. Ion to dipole, klaro kayo siya na mga ionic compound, i-add mo siya sa mga dipole. Okay, dipole molecules katong sa kuan, mga hydrocarbons, na polar hydrocarbons, mga ganun. Tayo pa sa polar. Yeah, the carbon monoxide. Okay, the carbon monoxide is polar. Okay, like that. Or the water also polar. So show them limits the structure, and then same method that I taught a while ago is just the same. You should look for the partially negative, partially positive, and combine with each other. That is the ion dipole. Ang emotion tipo na nililigayin na guys, ang ion is an ionic compound. Okay, plus and negative charges. Okay, like that. And then makabawi ka kay metal and non-metal siya. Okay? Get the point? Ang dipole katong create siya mga dipole sa between the other side and the other side. Okay? Just like the CO2 and the water. CO2, water, Cl2, F2, okay, fluoride gas, bromine gas. Kasi na yung mga two, guys, na siya dipoles. Okay, di2 man siya. Okay, two poles ba during the connecting of the electrons. So, mga-create siya yung two bands. 1, 2, gano'n. Diba? So, dipole. So, I have to show you what is a dipole so that kita maglibog, no? Charot. Okay. So, dipole. How can I explain the dipole? Charot. Okay. So, for example, I have water. Dipole po siya ang water, guys. But, gas-gas na kay water. We need to take the, ano lang siya, CO2. Okay? Okay. CO2. Why there is a dipole? Okay, in the bonding in the CO2 social term. I will explain. Okay? Like this. So, the central atom of this carbon dioxide is the carbon. Central atom. Okay, that is the first thing to do in the Lewis structure. You need to determine the principal or the central atom that needs to be bonded with the other elements that contains more than 2 subscripts. Here, oxygen have 2 subscripts. Okay, like this. Okay, so carbon in the center and oxygen will be on the outside or in the side, top, bottom, like that. Okay, let's say we assume that is in the left and right. Okay, like this. So I have carbon, valence electrons, determine the valence electrons. Okay, carbon. Okay, 1, 2, 3, 4, ganon. 4 valence electrons in the outermost shell because this is group 4A. Ganon. Now we have the oxygen. So since we have 2 oxygen, meaning oxygen in the other side, and the oxygen also in the other side. Ganon. Okay? Now, our purpose here is to emphasize the dipole interaction. Okay? D-I-P-O-L. So, diklaro kayo ha? Di. 2. Okay. Okay, and the pole meaning N. In English, N. P-O is a flagpole. So, meaning the end of the vertical, let's say the vertical pipe, that's a pole. P-O-L-E. Pinaka-end point siya. That's pole. Okay? The tip, T-I-P, that is a pole or the end point for any something that is a pole. Let's say, for example, the pencil pen, the last point is the tip or the pole of this pencil pen. Since there are 2 poles in this pencil pen here, so these are dipole. Ganon. You get the point? Why we terminate the S is wrong grammar in English? Because this is collective noun. Meaning to say a collective noun, okay, the term is still singular but can be applicable as a plural in form. For example, I have equipment. Equipment is also a singular form. At the same time, it is also a plural form. If you will say equipment, that's the wrong grammar. Because equipment is dual. It is also used as singular form, it's also used as plural form. So if you are clever in English, that is collective noun. Meaning to say, the plural form and the singular form of equipment is just the same. For example, you have two work equipments in your process area. You will say, I have two equipment. You will never say, I have two equipments. Wrong grammar. Again, because equipment represents also plural form. You get the point? So be careful in the grammar when you speak about technicalities because it's also a combination of technical and English. Something like that. You get the point, mga palangga? For example, I have also, let's say, bases. Okay, di ba? For example, I will say, this is my basis how I get this computation. And I have only one basis. So that is singular, B-A-S-I-S. But if I will say, I have so many bases how to compute this one, the spelling will change. That is B-A-S-E-S. The E as in eagle is the plural of the singular I-S in the bases. So many people will get wrong for this. Sure, even though the broadcasting, TV networks, okay, there's a lot of confusion about this because this is not common in English. Okay, for example, I will say analysis. If you have so many analysis, your spelling is not I already. It is A-N-E-L-Y-S-E-S, not I, because analysis I is only one. Okay, and then bases I is also one. If you have so many bases, then that is B-A-S-E-S. Sa tupa, you use E as in eagle, plural, I as a singular, in some noun that is collective. Okay, you get the point? Something like that. So collective noun. Okay, be careful also. Okay, it's gonna be like that. Going back to our chemical bonding of carbon atom and oxygen gas, the atomic molecule. Diba? So oxygen have 6 valence electrons in the outermost shell. Okay? Ganon. So guys, so if your son or daughter wants to take up BS Chemical Engineering, be ready because there's a lot of memorization. At least your son and daughter is good in memorization, particularly math and science. Okay, at least math, and then not so much in science as long as math, and then good also in science. And then English will be somewhere along the way because English will help you to interpret questions in the future because the questions are interpreted or, in English, declared in English language, generally or universally. Okay, so you can really answer if you have good, good analysis of terminology to terminology because you have to scrutinize that one. Okay? Because if you cannot understand the statements, you cannot solve what is being required in the problem solving, even though how good you are in math. Okay, I tell you frankly. Okay, if there are terms that you cannot understand in a certain problem solving, even though how very good you are in math, you can still not interpret that very, very well. Okay, you get the point. So advantage good with strong, English communication or interpretation of the particular phrasing, like that, statements, sentences, paragraph to paragraph, vocabularies to vocabulary, something like that. So you can easily understand, right? Because there's a lot of terminologies that will be used interchangeably in the problem solving. Okay, so going back to oxygen. Each oxygen atom has 6 valence electrons, right? Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Di ba guys, diba? Simple lang nga paano. So, oxygen atom. I will never say oxygen ion, right? Because it is not yet charged. Unless I will put on the board, I will put negative 2, I will say ion. Right? Then I discuss it as an atom when the words released in my mouth. Okay, that is chemistry grammar. Okay? I will never say oxygen ion, oxygen particle. Okay, because that is not particle. That is not an ion because it is not yet charged. Okay, that is still an atom. Okay, so oxygen atom, another side, oxygen, another side. Okay, ganon. So we have now 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Ganon. Parang tani parang connected siya mga palangga kung hitad. Diba? Mga palangga. Ganon. So, if we try to to determine the geometrical symmetry. If we study also deep chemistry, we need to understand the geometrical shape of each atom in the element, and you need to be familiar also what is a trigonal pyramidal, tetrahedral diagonal, something like that. So you need to, what is really the shape of a crystal of the ice? Ah, really? Well, that's the trigonal pyramidal. Ganun, di ba? So you need also to familiar the geometrical symmetry. Okay, the arrangement of your lattice ions. Grabe na kalalong. Lattice ions. Okay? Kay mga crystals din guys, lattice na siyang tawag, hindi na siyang molecules. Okay? Sa mga crystals, crystallization. Okay, ganon. Okay, now, oxygen after connect, we need to connect the electrons, 2 electrons of oxygen to the 2 electrons of carbon on the left side. Connect. Tadadat, tadadat, ganon. And the right side also, tadadat, tadadat, ganon. Okay. Now, carbon has a 4 valence electrons. The electrons of carbon has been totally shared. So, carbon with respect to 2 oxygen atoms is really a non-polar covalent bond because all electrons of carbon have been completely shared to 2 atoms of oxygen. Now, if we reverse that situation, what's gonna be the relationship of oxygen atoms to carbon atom? We will say that oxygen atoms are polar covalent band with respect to carbon because oxygen has 4 unshared electrons to the right and also we have 4 unpaired electrons to the left, meaning to say a total of 8 unpaired electrons unstable that needs also to react with other compounds. Okay? Something like that. But in this case, no other compounds. Well, the purpose of discussion only. Okay, ganon. So, okay mga palangga. Now, why it happens to be like this? Okay? Why it happens to be like this? Because it follows the octet rule. Okay? Octet rule. In the Lewis-Dot structure. Okay? Ganon-ganon, chupa-chuchu. Diba? In chemical bonding. Okay, Lewis-Dot structure. Si G.N. Lewis discover, guys. G.N. Lewis discovered the Lewis-Dot structures, the octet, something like that. And then he said the electron acceptor will be most likely an acid. Okay, the electron donator or the electron that will give electrons are basic. Okay, that is G.N. Lewis. Okay, because tulungan ko mas yan for the basicity and acidity. Because all compounds also has the nature of being acidic and being a basic. Because it measures the strength of each compound. That's why we need to determine the acidity of this particular compound. So, in this case, G.N. Lewis connect with this ionic compound. How to call that it is an acidic ionic compound, basic ionic compound. So we need to Lewis accept them on electrons, it's become acidic compound, and then donating, it will become a basic compound. It's not enough to say, that's ionic compound, that's a molecular compound. We need also to take the other concept of acidity and basicity, which is the measures of the strength of your compound. Could it be a molecular compound or could it be an ionic compound? Do not be confused with the inorganic compound, an organic compound, because inorganic compound and organic compound are classifications of compound. Classification. And this compound and molecular compound are types of compounds. So do not be confused with the words also in English, classification, categories, ganon, types, kinds, properties, natin na siya diferensya. Okay? For example, I will say, what are the types of chemical reaction? And you will say, irreversible chemical reaction and irreversible chemical reaction. It's not. That is classification of chemical reaction. Could either be reversible chemical reaction and irreversible reaction. The types of chemical reaction are those decomposition, combination, synthesis, double replacement, single replacement, ganon. Okay, those are the types. Okay, meaning the way it is being interacted. Okay, that is types. Okay, but the classification is only referring to the overview which it belongs. Let's say organic belongs to organic chemistry, inorganic belong to the inorganic chemistry. So meaning only the general, what do you call this one? Grouping, where it falls. Something like that. That's classification only. But we mean with types, it involves the characteristic or the nature of that certain compounds, elements, something like this. So, what are the two types? What are the types of elements? Ganon. O, maglibog na kung ka. You will say metalloids. Di ba? Means metalloids and then colloid suspension. Okay? It's not like that. Types of elements. O, non-metal and metal. Okay, ganon. Okay? You get the point mga palangga? So, ganun katiman andad sa English na description, ha? Then who knows, there are also enumeration. Kasi wala lang ko, i-treat lang ko na ito na enumeration or, sa examination, kasi wala. Multiple choice na lang. Okay, so, enumerate, ganun. Explain, define, outline, describe, sketch, ganun, illustrate, ganon. So those are the types of questions. True or false, ganon. And explain if false, explain if true, ganon. Okay? But more or less, in the board examination, there's no such like that question. Okay? You can guess. Okay? But ikaw, like that. But the only problem is there's a lot of choices to be done from A, B, C, D, E. So most likely you'll be in error also. Because the probability and stats is 1/5 times 100. There are 5 choices from A, B, C, D to E. And the correct answer is only one. So 1/5 times 100. So that is your percentage correct. Okay? When you answer the question. So dili po siya basta-basta kay 1/5. Pila man na imong makuha nga percent. So gamay ra sa kay chance. Unless there are 2 choices only, A and B. Okay, so your chance will be 50% to get the correct answer. But there's 5 choices, meaning 1/5 times 100. It's gonna be 0.25%? 25%, right? I don't know. I cannot estimate. I can use a calculator for that. Okay, 1 divided by 5, okay, times 100. Kuan siya mga 40 plus or whatever. Never mind. Okay? Like that. Now, this is now our CO2. The dipole moment, mga palangga, is diri ari. Dipole. Here, dipole. 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 Ganon. So, there are 1, 2, 3 dipoles in this CO2. Okay? Because the electron connect to another electron connect to another electron, so that is a dipole. So, upat na kabo, 1, 2, 3, 4 in CO2. Okay? Ganon. Okay. Muna siya ang ion to dipole. Nagugay ko sa ion to dipole. Sige lang. Okay, now we go to the number 4. Unsa man? The dipole to dipole. Since you understand already dipole, then connect that one. You can really easily understand, right? Okay, so dipole to dipole. Kaloka? Unsa man yung mga dipole to dipole? Okay, dipole to dipole. Mo ni siya kasagaran niyo guys itong mga kuan. Dipole to dipole, mga polar compounds, i-react mo siya. Nagyo na siya dipole to dipole. Why? Because di mo siya equal, not equal valence electrons. Mo ni mo timan-an, mag-dipole-dipole ka basta na yung mga polar compounds. You get the point? Just like water, ganon. Okay? Get the point? You get the point, mga palangga mo siya may tabi. Okay. Dipole to dipole. For example, okay, water plus methanol. Ganon. And then, water plus carbon monoxide. Ganon. Okay? And then, we will say also, sige, hindi na siya water guys. Pwede siya gawin mo na carbon monoxide plus methanol. Basta, dili balance ang iyang valence electrons. Na yung mga dalang yung mga shared electrons. So, possibility dipole-dipole na siya. Okay? You get the point? Okay. Because if we try to illustrate everything, it will take a longer time on the same concept, right? Okay? Like that. This dipole to dipole. Okay. So, ibig pala sabihin guys, ang hydrogen bonding will also exhibit dipole dipoles in case of a water lang. Water. Okay? But the others will never go through. Of course, because you know, the CO don't have hydrogen there. So it will not be called a hydrogen bonding. But in case of water, the water will exhibit also dipole to dipole. Okay? For example, water will exhibit what type of chemical bonding? A, ionic bonding. B, van der Waals weak forces bonding. London dispersion forces bonding. There's a lot of bonding, di ba? Ion to dipole bonding. Ion to ion interaction. Letter E, as hydrogen bonding. Letter F, dipole bonding. Letter G, both E and F. Your answer will be both E and F because it can extend as a hydrogen bonding at the same time dipole to dipole bonding. Because there are also questions like that, both A and B, both C and D, like that in the choices of the question. Okay? And you need to think that out also. And sometimes also have none of the above and all of the above. Something like that. Okay? So if the answer is not there, none of the above, and if you think that all the choices are the same, have the same answers, then, or you know, so you need to say all of the above. Ganon. Okay? Klaro na siya guys mga palanggan, mag-exam na ta sa chemical bonding. Charot. Okay? So kung why bonding, wala dito yung mga materials. If we don't have chemical bonding, we cannot produce materials around us because most of the, you know, the t-shirt, the shirt, the cell phone, anything around us are chemically bonded with different metals and non-metals. Okay? So that's why chemical bonding is very, very important. This is part of having a successful world, chemical bonding. Okay? Like that. Imagine if you cannot bond the concrete and the water, so there's no foundation in your building. Because you have to put water, and water is a polar molecule. And there's a bonding also with the grating. You you get the point, something like that. Or the grout, GROUT substances. Okay, then you put that one, like a powder, like a cement, like that. And if there's no chemical bonding, it will not stick together. Okay, that's an example of a chemical bonding. So we don't have the ridges, the spoon, and everything because we need water in that for the mixing of the concrete, gravel, sand, like that. See? So we need to say all around us is made up of chemical bonding and chemical reactions. Okay, so there's no chemical reaction. We don't have t-shirts, we don't have a pillow, we don't have bed sheet like that, or we don't have cell phones. Cell phones also bonded with different metals. The zinc, the whatever, the palladium, like that, the zinc, the iron, the copper, the construction of materials of our cell phone. So that's also chemical bonding. Okay? So we need to say, chemistry is around us and we cannot survive without chemistry. Okay, something like that. Okay. We are just only taking for granted because it sounds boring and very academic. Okay? And we don't want academic. And we don't need to sharpen our minds because it needs us to think a lot. And it suffers our brain cells. Our neurons will suffer also if we keep on thinking about academic. That's why you need to do that. Okay? We will just laugh, listening to jokes like that, watching sports. Because those stuff doesn't need to sharpen our brain cells. All we have to do is to sharpen our eyes. Okay? And to sharpen our ears to listen what they are talking or what they are announcing in the particular games or whatever. But our brain will not be sharpened. Unless you will go and research and read some information. In that way, your brain cells, neurons in your brain cells will help to activate. Okay? Things like just only watching, it never helps us to think. It can never sharpen our brain cells. Okay, by just watching only movies. Okay, now, admittedly, because who wants to sharpen our minds all the time? Our brain cells will be, keep tired. Normally, by common sense, out of 10, only one something like that, because they love to smile, because laughter is the best medicine, something like that. Okay, you get the point. So that's why academic information vlogging sounds boring to the majority. Especially if they are now graduating, or graduated in their course, they will never care anymore because they are now in the real world. But actually, if you try to dig it out, okay, we cannot survive without chemistry. Okay, something like that. And it helps a lot also to avoid diseases and sicknesses also, because you are not particular what type of food we're going to eat, because it can react to other substances that it can produce dermatitis. Okay, it will produce abdominal pain, it will produce headache, it will produce the weakening of your bone, the osteoporosis and the osteomalacia. If you have a lesser content of calcium in your body, your bones, something like that. So we need also, and that is also chemistry in combination with medicine and epidemiology. Okay, apart studying the the physiology and the anatomy. I'm not a doctor, but I need to research related to doctor of medicine topics also. Okay, it's not enough that if you are just having that course, you will never expand also your knowledge to other specialization. Diba? Muna siyang natabo karon kayo na. Okay. You get the point? But we need to be balanced mentally and physically, spiritually, morally, chuba chuchu, and socially. Wow, nakakaloka. Okay, thank you so much for watching also for this vlog. Mga palangga kong hita, this is all about chemical bonding. Later, I will be able to discuss the relationship between, electrons characteristics. Why these electrons are coming to our world? Why we need electrons to survive? Oh, remember, we as a human being, we have stored electricity in our brain cells, in our vital organs. If there's no electricity in our vital organs, it's not easy also for us to have energy in our day-to-day life. We have a source of electricity, stored electricity in our body, because I told you, we always intake water as a polar molecule inside our body. And there's a polarization exists in our body through the reaction of different cells and different tissues inside our body. So meaning to say, the electrical energy is not functioning only in the outside world. It's also in our system, in our body, in our digestive system, and also with the correlation of the vital organs in the respiratory system, central nervous system, especially the electrical impulse. Remember, electrical impulse in our neurons, okay, needs electricity, guys. Okay, especially also the cellular membrane of our vital organs. Okay? You get the point, mga palangga? The lipid. Oh, it needs also electricity because it will be polarized, so that it will be open, so that substances will go in. It will be closing when the substances will not be accepted. Something like that. Opening, closing, opening, closing. If there will be no opening, how can the substances will go there? And to achieve the nutrients that we have in order for us to survive and keep to be able to be healthy, or like that. So meaning to say, there are electrical impulses in every vital organ we have inside our body. So meaning to say, electricity is inside our body. Okay, that's why chemists really studying also electrochemistry and electromagnetism, because it will be applied in biochemistry, the combination of biology and chemistry normally inside our body. Okay, or in the living organisms, in the interaction between plants and animals and the organisms and our habitat, that is our ecosystem. Thank you so much. Thank you so much for watching this video. Guys, I love to vlog also another type of chemistry. It's environmental, I love it also. But I still have to focus more on the, theoretical aspects before going to the environmental chemistry, okay? Environmental chemistry is very, very interesting. Really all about environmental monitoring. So before going there, we need to have foundations first. These things that I discussed to you. Okay? The environmental science is a general broad topic in which environmental chemistry belongs to that. Okay? Ganon. There's a lot, guys, okay, for it will take us, 1,000 years if you will study everything about pure sciences. Okay, thank you so much, mga palangga. If you like this video, you can comment down below in the comment section. You can share if you wanted also about academic information. And then you can click the bell notification for some newest updates of I Am a Singer Channel Voice. And you can also subscribe to my YT channel if you haven't subscribed yet my YT channel. And also you can also take a look with my other YT channel, also the exclusive singing, in which that YT always have musical inclination, all about singing. But if you don't want, try this. Also, IT channel is more about academic information and everything. Okay, sometimes I sing, but limited because due to copyright issues. Okay, if your vlog will be copyrighted and then there's no revenue after that. You get the point? So I cannot sing using the karaoke YT music because it will be copyright and my time will be useless. I will not receive income for that. Okay, that's why I need to do this because this is originality. Originality meaning you are not copying from other sources because if worst scenario or worst cases they were filing a case against you. I'm not a lawyer, but the term there is plagiarism. When you are trying to copy the other articles from other authors, and you to copy that one and show in your blog, so that's the act of plagiarism. Okay, meaning to say you are infringing, okay, the content of other bloggers, and you try to share that again and again. So you have to put disclaimer every time, disclaimer or sources after your description. If you want to reshare, okay, or else you will be terminated in the YT channel. So it's very strict. The YT administrator is very, very, very strict. Okay, there are rules to follow, something like that. And I cannot make also singing in this platform, guys. Sorry for that. Okay? Ganon. Kasi ako ba, ma-expect, kanta na sa June, oy, pagkantahon niyo ko sa akong YT channel dali ali. Oh, atong sa Pikas, sa exclusive singing, may other YT channel. Okay, you get the point? Di ba to siya monetize, guys? So okay lang ang copyright. You get the point? Oh, mana siya mahitabo. Di jud madaog kuan, guys, fair use content tanan. Okay, fair use content meaning not for commercialization purposes, only for educational purposes, like that. Your goal and purpose is not to commercialize the contents and the articles of others. So that is fair use law in social media. You get the point? But if you try to commercialize that one, you gain money, so you are violating now, okay, the copyright law of social media. And then if worst to worst cases, you will file a case of plagiarism, and then cyber case will be filed also to you. Okay, cyber crime, because you are trying to sell contents or materials that are not belong to you. Get the point? So we need to be, extra careful also. Get the point? And sometimes, no. Thanks to God, I don't receive any warning in my channels. Okay? Thank you so much. Thank you so much for watching my videos. I hope you like it. Thank you. Bye-bye. God bless everybody. See you later for my next vlog. Mga palangga kong hitan. Okay. Bye-bye. Kaloka. Nakakaloka.